You know the feeling. You're alone in a room, reading, working, half asleep. And something shifts. The back of your neck tightens. Your shoulders go still. Somewhere underneath your thoughts, a quiet voice says, "Someone is looking at me." You turn around. Nobody is there. You feel a little stupid, and you go back to what you were doing. But your body does not go back. For a few seconds, your heart is faster than it should be. And a question sits there, unanswered. If nobody was watching you, what exactly just happened? The honest answer is stranger than a ghost story. Because that feeling is real. It is not your imagination inventing something out of nothing. It is a machine in your brain doing exactly what it was built to do, running a calculation about eyes. And once you understand that machine, the feeling never looks the same again. Start with what your brain does with faces. It is obsessed with them. There is a patch of tissue behind your right ear called the fusiform face area that lights up for faces and almost nothing else. That is why you see faces in clouds, in electrical sockets, in the front of cars. Your brain would rather invent a face that is not there than miss one that is. But faces are only the first step. What your brain really wants is the eyes. In the 1990s, a research team led by the neuroscientist David Perrett, working with macaque monkeys, found something remarkable in a region called the superior temporal sulcus. There were neurons that fired only when a face was looking directly at the animal. Turn the face slightly away, and those neurons went quiet. A different set fired for a face looking left, another for a face looking right. Deep in the brain, below any thought, below any decision, there were individual cells whose entire job was to answer one question: are those eyes pointed at me? Humans have the same machinery. And we have something extra that makes it far more powerful. Look at your own eye, a dark circle sitting in a wide field of white. Now look at a chimpanzee's eye. The white part, the sclera, is dark. A gorilla, the same. An orangutan, the same. Out of hundreds of primate species on this planet, ours is the one with a bright white eye. Think about what that white does. It is a spotlight. It turns your gaze into a signal that can be read across a room. In 1997, two Japanese researchers, Hiromi Kobayashi and Shiro Koshima, published a study in Nature, comparing the eyes of nearly 90 primate species. Humans were the outlier. They argued that our eyes evolved to be red, that the white sclera exists so that others can see exactly where you are looking. The psychologist Michael Tomasello later built on this with what he called the cooperative eye hypothesis. Every other primate hides its gaze, because gaze is information and information is power. A chimpanzee does not want you to know what it is looking at. Humans went the other way. We evolved to advertise our attention, because we were the species that survived by pooling attention rather than hoarding it. Your gaze is not private. It never was. It is broadcast. And that means every eye you have ever met was built to advertise where its attention is going. And every brain you have ever met, including yours, was built to detect that advertisement instantly. How instantly? Faster than you can think. Research by Atsushi Senju and Mark Johnson on what they call the eye contact effect found that direct gaze is detected extremely rapidly and triggers a cascade of responses before conscious recognition even finishes. Your brain knows you are being looked at before it knows who is looking. And being looked at does things to your body without asking permission. Your pupils change. Your skin conductance rises. Your heart rate shifts. The amygdala, the part of your brain that handles threat and salience, gets involved. The eyes reach in and touch your nervous system before your opinion arrives. Here is the part that should genuinely unsettle you. Your brain does not need a real person to trigger this. It does not even need a real face. 2 dots and a line will do it. In 2006, 3 researchers at Newcastle University, Melissa Bateson, Daniel Nettle, and Gilbert Roberts, ran an experiment in their own department. There was an honesty box in the coffee room, the kind where you drop in money for the tea you take, with nobody checking. Above the price list, they hung a small image. Some weeks the image was a picture of flowers. Other weeks it was a picture of a pair of eyes. Nothing else changed. Same coffee, same prices, same people. In the weeks with the eyes, people paid nearly 3 times more money into the box. Nobody was watching them. It was a photograph, a piece of paper. Everyone in that room was a professional academic who knew perfectly well that a printed pair of eyes cannot see. Their behavior changed anyway, because the eye detector does not consult your opinion, it just fires. That is the machine. Now here is why it makes mistakes. Imagine two of your distant ancestors sitting in tall grass at dusk. Both of them feel a flicker of being watched. The first one turns around. There is nothing there. He feels foolish, and he goes back to his food. Cost of the mistake: a few wasted seconds and a bruised ego. The second one does not turn around. There is nothing there. He was right. He saves himself the trouble. Now run the same scene again, but this time there really is a predator in the grass. The first ancestor turns, sees it, and runs. The second ancestor does not turn. Cost of that mistake: everything. That imbalance is the whole story. This is what the psychologists Marty Hasselton and David Buss formalized as error management theory. When the two ways of being wrong have wildly different prices, evolution does not tune your brain for accuracy. It tunes your brain for the cheaper mistake. A false alarm costs you seconds. A missed alarm costs you your genes. So any brain built by that math will fire early and often and at shadows. Because the shadows are cheap, and the tiger is not. The anthropologist Justin Barrett pushed this even further. He argued that humans carry what he called a hyperactive agency detection device. Not just a system for detecting eyes, but a system for detecting minds. Something moved in the bushes. Is it wind? Or is it someone? Your ancestors who assumed wind and were wrong got eaten. Your ancestors who assumed someone and were wrong lost nothing but dignity. So we inherited brains that see agents everywhere. In storms. In illness. In luck. In the creak of an empty house. Your gaze detector is not broken when it goes off in an empty room. It is a smoke alarm. And smoke alarms are supposed to scream at burnt toast. But there is one more layer, and it is the strangest part. Your brain is not passively waiting for eyes to appear. It is constantly guessing. Over the last 2 decades, neuroscientists including Carl Friston, Andy Clark, and Anil Seth have built a picture of the brain as a prediction machine. It does not assemble reality from raw sensory data each moment. That would be far too slow. Instead, it builds a model of what is probably out there, and then uses the senses to check and correct that model. Anil Seth has a phrase for what results. He calls it a controlled hallucination. What you experience is not the world. It is your brain's best guess about the world, held in place by the senses. Which means your sense of being watched is a prediction, and predictions get made with whatever evidence is lying around. A faint sound behind you that you never consciously registered. A shift in the light. A cold draft. A change in how the room echoes. A shape at the very edge of your vision. That your visual system processed and your conscious mind never received. Your brain quietly assembles these fragments, runs its calculation, and returns a verdict. And notice how the verdict arrives, not as a sentence, not as a thought. It arrives in your body as a feeling. You do not think someone is watching me. You feel it in the skin on the back of your neck before you have any idea why. Here is the proof that this is a guess and not a sense. Scientists have tested the feeling directly, and they have been testing it for a very long time. In 1898, the psychologist Edward Titchener wrote about students at Cornell who were absolutely convinced they could feel a stare from behind. He tested it in the lab. The effect vanished. Since then, the experiment has been run many times, in many forms. People sit with their backs to someone who either stares at them or looks away, chosen at random. Then they guess. Across the accumulated attempts, people perform at roughly chance. Their bodies give them a feeling. The feeling is completely real, but it carries no reliable information about what is happening behind them. It is a signal from inside, not a message from outside. And now consider what happens when this machine is fed almost nothing. A dark room, a quiet house, 2 in the morning. Your prediction engine is starving for data, and it still has to produce a guess. So it fills in the blanks, which is exactly when a coat on a chair becomes a person, a creak becomes a footstep, and an empty hallway develops a personality. You are not being irrational. You are running a prediction machine in low light, and the guesses it defaults to are the ones that kept your ancestors alive. There is a beautiful consequence to all of this, and it turns the whole feeling around. That uncomfortable prickle on the back of your neck is not a malfunction. It is a receipt. It is proof that you belong to a species that survived by watching each other. Your ancestors had no claws, no speed, no size. What they had was a group, dozens of pairs of eyes, all with those bright white sclerae, all silently broadcasting where the attention of the group was going. When one person's eyes snapped toward the tree line, everybody knew. Knowing who was watching you was how you knew where the danger was. It was how you knew your standing. It was how you knew whether you were still inside the circle. And the circle was survival. You did not inherit a paranoid brain, you inherited a social one. A brain that never stops asking where everyone's attention is pointed. Because for a few 100,000 years, the answer to that question was the difference between living and dying. The empty room is the new part. The room is a recent invention. Solitude is a recent invention. The machine was built for a world where you were almost never alone, and where a pair of eyes in the dark was a fact, not a feeling. So the next time it happens, when the room is empty and your neck prickles anyway, go ahead and turn around. There will be nobody there. But now you know exactly what just happened. A system older than language, older than your species, weighed the cost of being wrong and decided that you should look. Nobody is watching you. Something inside you is just very, very good at checking.